Sound. We are familiar with different forms of energy. What is light? Light is a form of energy that produces the sensation of vision. What is heat? Heat is another form of energy that produces the sensation of hotness. Like that, sound is a form of energy that produces a sensation of hearing. How is sound produced? Sound is produced due to the vibration of objects. When you pluck a stretched rubber band, it produces sound. When you hit a drum, it produces a sound. When you clap, you can hear sound. So, in all these cases, what is happening? At the microscopic level, particles are vibrating. So, the production of sound. Sound is produced when objects vibrate. Here are some examples: tuning fork, guitar string, drum, vocal cord. When we exert a force, they will produce sound because of their vibrations. When we talk about vibration, we need to look at vibratory motion in detail. What is oscillation? The to and fro motion of an object about a mean position is called oscillation. What is the difference between oscillation and vibration? Vibration is an oscillatory motion which is very fast. Consider this example. Here you have a particle. When the particle is at rest, that is, there is no disturbance, in that case, the position is called mean position or equilibrium position. When it is disturbed, what will happen? It starts to vibrate about the mean position. It moves to one extreme, comes back to the mean position, moves to opposite extreme and come back to the mean position. So, this motion is called vibratory motion. This is a vibratory motion, this is a vibratory motion and this is a vibratory motion. In all these cases, this particle is vibrating about the mean position. Propagation of sound. We have said that sound is produced due to the vibration of a body. How is sound propagating? It is also due to the vibrations of particles in the medium. See, here you have one example, a source which is producing sound and a listener. And there are so many dots here. These dots are representing particles. So, when an object vibrates, the particles which are in contact with this object starts to vibrate. So, a single particle will carry the disturbance to the immediately next one. This particle exerts a force on the second one and come back to the mean position. This disturbance is carried on to the next one by the second one. In this way, the disturbance travels through the medium from the source to the listener. This disturbance is called a wave. See, based on the requirement of medium, waves are classified into two, that is mechanical waves and non-mechanical waves. We have said that sound is requiring a medium for its propagation. So, what is a mechanical wave? Mechanical wave is a wave that requires a medium for its propagation. Mediums like solid, liquids or gases. Non-mechanical waves are waves that do not require any medium for their propagation. That is, no medium is required. Light is a non-mechanical wave because light does not require a medium for its propagation. And again, the mechanical waves are classified into two, longitudinal waves and transverse waves. What are longitudinal waves? If the particles of the medium are vibrating parallel to the direction of propagation, then they are called longitudinal mechanical waves. The particles are vibrating perpendicular to the propagation of wave, then they are called transverse waves. So, sound is definitely a mechanical wave and it is propagating as a longitudinal wave. When sound is propagating through the medium, different regions of low pressure and high pressure are created. Here you can see this is a low pressure region and this is a high pressure region. Or we can say that this is a low density region and this is a high density region. See, these regions are called compressions and rarefactions. What is a compression? High pressure region, that's a compression, and low pressure region is called rarefaction. You can see here there is a rarefaction, compression, rarefaction, compression, rarefaction, compression, and this continues. So, propagation of sound can be visualized as the propagation of density variations or propagation of pressure variations as rarefactions and compressions. So, the distance between two consecutive compressions or rarefaction is called wavelength, which is denoted by the letter lambda. See, we are taking the distance between two consecutive compressions. So, from this point to this point, we measure a wave or wavelength, or else we can say I am considering two rarefactions. See, the distance between two rarefactions is again a wavelength. So, this situation can be represented graphically, and this is shown here. This is a form of a wave, and each wave is representing a single vibration. See, this wave is having a peak and a valley, and this peak corresponds to compression or high pressure region or high density region, and the valley represents a low pressure region.